So first thing I want to go over are just the major concepts, make sure you've got it. You're all coding up this equation and we're calling it assignment 1, right? We're all on the same page there. Next question, do you get what this equation does? It's computing m and b, and these are the parameters for a linear model that fits to your data, right? Okay. Now the question, where did these equations come from? And the answer is not the book, page 158. I mean, they came from there, but they came somewhere else, from somewhere else first. Could you get those equations? Now, there's a lot of math between here and there, and I never walked through the derivation for you, and you can do that by hand, but I'm not really interested in can you do the math at this point, although really it's kind of simple math. I think you should be able to do it. I recommend you do walk through the derivation, but I'm not going to force it on you because we have other things to cover in this semester, and you can leave that up to wolframalpha.com if you want to. Is that fair? Okay, but what I do want you to get is how to get to this point, assuming you have access to wolframalpha.com or Mathematica or your favorite auto solver for math, or a mathematician or something like that. So if you had a mathematician at your disposal and you could not remember this equation and you didn't have the internet or this book, could you get this equation? You think you could? If you could, I'm totally happy. Where would you start? Yeah, and the way we know that is we scroll way up to where this thing starts. And I start with sum squared error. Okay, first question, why sum squared error? Why did I start here? Yeah, because this metric, what this means is how badly my model fits to the data. And I want my model to fit goodly to the data, so I want this to be as small as possible. The less badness, the more my model is a good model. Does that make sense? So it's just because of what this equation expresses. And you see that it's expressing here for every data point. In fact, that would be a great test question. What the heck am I summing over here? And that you should answer all the data points that you know, all the evidence that you have. Okay? So for every piece of evidence we have, we're going to ask the question, how different is the real answer from the answer we predict? And mx plus b is our prediction, and this is the answer we wanted, and the difference squared summed up is sum squared error. So you get what that is, right? And you get why we're starting there and why we want to minimize it. So the next question, how do you minimize an equation using calculus? And the answer is take the derivative and set it to 0, right? So that's what we do. Right here we take the derivative and we set it to 0, and then we solve. Math, 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 math. And we arrive at these equations, and now you totally understand everything you did in assignment 1, right? And by totally, I mean maybe you're having some coding issues and you're hacking it together, but at least the theory totally clicks. Are you with me? Any questions at all? Okay, good. Well, we're done with the theory then. Let's move on to the practice. How's your coding going and any issues? I'll start. There's a coding issue that came up. Somebody found that the Java version of the starter kit has a matrix class in it, and the matrix has a multiply method, and that multiply method crashes in the case where you transpose one of the matrices and not the other one. Anybody found that? Okay, sorry. Yeah, I thoroughly intend to fix it. In fact, can we just fix it right now? Does anybody know the answer well enough? You could help me out a little here. Maybe. Or how about this? Somebody post the solution on the forum, or if I beat you to it, I'll go fix it and I'll get fixed in the starter kit, and that'll help you out so you won't have to debug it. But if you do encounter that issue, basically there's a loop that's going across columns and it's supposed to go across rows, Or maybe it's going across rows and it's supposed to go across columns. It's one of those is switched. So when it crashes, you'll get an exception, and that'll tell you where the problem is, and then you'll know how to fix it. So now you're all unblocked, right? Okay, that was pretty weak sauce. I will try to fix it as soon as I can, and let's post it on the forum and get this issue out of the way. I'm sorry for that. Anything else? Yes?
On the forum, you said that the neural network class was supposed to have a vector full of all the weights for each layer that we're going to eventually be putting in there. I was just wondering what the reason for that design choice was.
Okay. So the question is, let me actually get to where it says that. I'm a very visual person, and I have to see where it says it, and then it'll remind me why I said that. Okay, let's see. Make a class named neural net. Well, it does say right here, the vector weights is a big vector containing all the values needed to fill both M and B.
That's in the linear class, but you said that.
Okay. You're right. So make a new class named neural net, which holds a collection of layer objects. Had a method named predict that takes a vector and train ordinary squares weights. Okay. Yeah, I remember writing that. At some point after here, I say, hey, you're going to have some weights for this neural network, right?
It's right in the middle there.
Okay. Oh, there it is. Add a member variable of type vec to hold the weights of the layers. Sometimes I give instructions that are trying to be helpful and aren't trying to be, thou art required to do it in this manner. And I think this is one of those. At the time I wrote this, I thought this would be helpful to you. If you find this line to be unhelpful, please feel free to just ignore it. This is me kind of holding your hand more than I should. You are going to need a vector of weights. And that vector is going to hold the weights for everything in the whole neural network. We're eventually going to have a neural network with lots of layers, and every layer is going to have weights. And you're going to want to be able to say, here are the weights for this one neural net. And storing it in a vector is a great way to do that. But you do not have to have it be a member variable of the neural net class if you don't want to. You could just carry around your neural net and your weights vector, and as long as you keep them together, that works. Putting it in the neural net makes sense. There's lots of other ways that could make sense. So that's not some kind of a requirement, and I apologize for not being more clear. Is that good enough, or you're looking more for the intuition?
Yeah, so I put each weight vector inside the linear or the layer class.
Okay.
And I was wondering if that was going to be a pain to work with.
So there are some good reasons why it's good to separate your architecture from your weights. And the main one is if you start parallelizing the thing, meaning you want to run on multiple different threads at the same time, you're going to have all kinds of concurrency issues. So I'm trying to give you an architecture that will scale if you need to. In this class, however, we will not be running on multiple threads in parallel. So some of my architecture is trying to build a neural network that mirrors the ones in TensorFlow and is such that you could keep going with it a lot more than is really necessary. If you wanted to stick your weights in every single layer, you can totally do that. Some of my instructions later on are going to assume that you've got your weights in one big vector. And so if you've got your weights in little pieces all over the place, you'll have to kind of interpret for yourself, oh, my vector's spread all over the place, so when he's just doing vector math now, I need to kind of do the equivalent to all the pieces of it so that the same math is accomplished. And as long as you're prepared to do that, please feel free to redesign it your own way. I think that's the complete answer. Yes?
So when it says a collection of layers, there's lots of different kinds of collections, what do you call it?
Yep.
Structures you can use?
Linked list, array list, etc.
Yeah, I chose array list. Is there a
Okay.
particular one that's one
No, I think all of them are sufficiently fine. You are going to have to iterate through them forward and backwards. So if it's a linked list, you'll need a double linked list probably. I like array lists because you can index them arbitrarily. Whatever collection would be fine. Yeah. And we're talking about layers that are going to get as deep as maybe 6 to 8 layers, not hundreds to thousands. So even if you use some ridiculously slow data structure, you'd probably be fine. You'd never even notice the difference. Okay. Any other questions? Yes?
So the vector weights, earlier weights was like n plus b, like together. Are you saying it's a vector of a bunch of those together?
After this assignment, it will be M's and B's in all the layers in the whole neural network. Yeah. It'll be a whole lot of stuff crammed into one vector. And we're going to take subvectors of it for each layer when we do the math. So as we're getting ready for our next assignment, yeah, that's the way to look ahead.
Should they be like separated by which layer they're for, or should it be just like one incredibly long, like here's all the weights for this layer, and then at the very end of it starts the next?
I don't quite understand the difference. I see those as being the same. But yeah, it's basically all the weights for all the layers globbed together into a vector. Okay. And then you can say, hey, this is the set of all the parameters for this model. And then you could drill down and look a little more closely later on. And if you end up having to rewrite a little of this for the next assignment, that's not such a big deal because when you know what you're doing, these things go really fast. It's when you don't that they don't. So in my opinion, just get the assignment working and then worry about the next assignment when you get there and you should be okay. But if you really want to save a lot of time, yeah, it's going to be like that. Yes?
So what's the difference between storing it in a big vector, between a store path parameter as array of vector and array of matrices?
What's the difference? From a theoretical perspective, math doesn't care what part of memory it's stored in or how broken apart it is. As long as the same numbers come out in the end, you've done it right. So there is no true answer, no right structure. However, students tend to get into traps where it becomes really hard to code around weird structures because they've broken it up certain ways. I've tried to avoid that by suggesting you do it this way, but there's nothing about my suggestion that is correct. This is just style and coding. So yeah, don't read too much into anything I give you about how to architecture code. The math, if you do the math right, you've nailed the assignment. If you build the architecture according to my directions, then it will turn out the way I envisioned it, and that doesn't matter at all. Okay. Anybody having issues with your language that would be worth addressing here? There's usually a few gotchas, especially in C++, that I like to mention just because otherwise people spend hours chasing down the issues of the language. Are you doing okay with C++? Or anybody want to